All right, folks, this is Mr. H here, and I'm going to walk you through how to complete practice file 2-2. This is a projectile. This object is moving through the air only under the influence of gravity. So, things that we're going to look at today here are, if you have an initial vertical velocity and you're under the influence of gravity, what is going to happen to that vertical velocity? And this object also has some horizontal velocity to it, or Vx. So we are going to be traveling up and down, Vy, and horizontally, Vx. What does that look like? Well, when you throw something upwards, we know that what goes up must come down, right? It goes up at 30. In this case, it's going to slow down, and eventually stop. We also know that once it reaches the top, gravity never turns off, right? So gravity is going to continue to accelerate this object, but back the other way. So it's going to speed up downward, speed up downward, speed up downward. Okay, so slow down, stop, speed up, speed up, speed up, speed up. Now, this object is not just going up and down, though. It's also traveling to the side. So it's traveling at 5 at the beginning, 5 after 1 second. This vector here appears to be about the same length. Well, that's very intentional. It's not a coincidence, okay? The horizontal velocity of an object is constant as it moves through the air because gravity, folks, only acts up and down. So our vertical velocity will be changing, but our horizontal will be the same. So what they want us to do here is just find out what are our vertical and horizontal components on the way up. And then on the way back down, they want us to figure out what is the total velocity. So this is pretty easy to do. Let's find our Vy's, our vertical velocity. The way we're going to do that is Vf equals Viy plus At. So how fast you're going depends on what was your vertical velocity at the start, what is your acceleration, and for how long. So we know at the very beginning we're launching up at 30. Okay, gravity, folks, is going to be pointed downward, right? So if gravity is pointed downward, and we're saying our initial velocity is positive 30, gravity has to be negative, guys, because it's pointing the other way. So we're going to use negative 10 for gravity here, okay, because it's going to oppose the motion of the ball. And we're going to figure out how fast we're going after 1 second. So our Vf is going to be 30 meters per second plus negative 10 meters per second. So our Vf is going to be 20 meters per second after the first second, which makes sense because, right, the ball goes up, gravity slows it down by 10. Right, so we're going to have 20 meters per second here. Okay, if you do the same approach, right, you're going to see that we're going to slow down even more when we get to this position here. So let's go ahead and throw the numbers in and see what we get again. We're going to go Vf equals 30 meters per second plus gravity, negative 10 meters per second squared. But now we're looking at it after 2 seconds. So we're going to go 30 plus negative 10 times 2, which is negative 20. So 30 meters per second minus 20 meters per second. Our velocity after 2 seconds will be 10. So we've slowed down by another 10, folks. Again, this is very predictable. We know that gravity, right, accelerates you by 10 meters per second squared, or 10 meters per second, pardon me, every second. Now, notice we do not have a vertical velocity. We don't have a Vy at the top. That's not an accident. We know that if we go upwards for another second, we're going to slow down by 10. So we have reached the top here. Our Vy at the top is 0 meters per second. So what we see is that we still have a component here, right? We still have a horizontal velocity because, guys, we have a horizontal velocity that is constant. Okay, so when you throw something upwards, the vertical velocity changes because projectiles are only under the influence of gravity. Gravity only acts up and down. Okay, gravity does not act side to side, so the horizontal velocity, folks, is going to be constant. It will always be whatever it is at the beginning, which in this case is 5 meters per second. Okay, so what they want us to do after the top is they want us to figure out now what is the total velocity on the way back down. In order to do that, we're going to need to find what our vertical and horizontal components are, our Vx and our Vy, so that we can do Pythag. Okay, because we'll have our A and B, our two sides of our triangle, we'll be solving for C. Okay, so this is pretty easy. I'm going to go ahead and color code it here. We're going to take our horizontals, and they're always going to be 5. Okay, we know that the horizontal velocity is constant, so this is 5. This is 5. This is 5. It's always going to be 5 because our horizontal velocity is constant. There is no horizontal gravity. It's only vertical. So vertically, though, of course, our velocity is going to change because now we are essentially under free fall, right? We're at rest and then we fall, only under the influence of gravity. So gravity, remember, speeds everything up by 10 every second it falls. So we can assume if we're at rest, after 1 second, we'll be going 10 meters per second down. After 2 seconds, we'll be going 20 meters per second down. And after 3 seconds, we'll be going 30 meters per second down, right? Speed up, speed up, speed up. This is what we've done a million times in class, right? Slow down, stop, speed back up, all right? It's just falling. So all we need to do here to find our total velocity is just do Pythag with our 2 sides of our triangle, right? Because think about it. This is our vertical component. This is our horizontal. They make a triangle. There we go. All right, same thing here, right? Here's our horizontal. Here's our vertical. There's a right triangle. So we're just going to do Pythag really quick. The equation's already right here, right? A squared plus B squared equals C squared. So our vertical component here is going to be 10 meters per second, square it, plus our horizontal component is 5 meters per second, square it, equals our hypotenuse, C squared. 10 squared is 100, 5 squared is 25, so we get 125 equals C squared, and then we just root both sides. I believe we get 11.8 meters per second is C. Okay, so we're not just going 10, right? We're actually going a little faster because our horizontal and verticals add up to give us a slightly larger velocity. So we're going down and right at 10. We can go ahead and do the same thing here. Okay, we'll do it for 20 meters per second of vertical velocity plus 5 meters per second of horizontal, and that will give us our hypotenuse. A squared plus B squared equals C squared. Okay, so we're looking at 20 squared, which is 400, 5 squared, which is 25. So we're going to take the root of 425. All right, so we got 425 equals C squared, root it. And we are looking at 20.6 meters per second equals C. Okay, so again, a little bit faster, moving down and right. And gravity is speeding us up as we go downward. And then our final vector, right, is going to be something like this. Again, we take our horizontal and vertical components, and those give us our total velocity. We're going to be going even faster here, of course, because we've sped up vertically to 30 meters per second. So we'll square that, plus our 5 meters per second of horizontal velocity, and that will give us our total velocity. So we're doing 30 squared plus 5 squared, so we're going to do 900 plus 25, so we need to take the root of 925. If you do that, you should get 30.4. So 925 equals C squared, root it, and we should get 30.4 meters per second is C. So what we see is that our projectile slows down as it approaches the top until it reaches the peak. At this point, it has run out of vertical velocity. Okay, just remember here, very, very important, the horizontal never goes away. This thing is always moving to the right at 5. So even at the top, it doesn't actually stop. It stops going up, but it's still going to the right. Okay, like if you ever watched a football game, the ball doesn't just totally stop at the top, right? It's still going to the right at the peak. So vertically we stop. On the back end, we're going to speed up. We're going 30 down, 20 down, 10 down, 20 down, 30 down, which means if you combine that with the 5 meters per second, we're going faster and faster and faster. The result is a parabola. Slow down, stop, speed back up. It gets vertical, very vertical at the beginning, and then very vertical at the end. Please double check that you have all of this filled in. We'll come back tomorrow. We're going to look at horizontal projectile specifically. Make sure you have your reading guide and Vector 1 WebAssign from last week done. Thanks, and I will see you tomorrow.